The project was, let me say, conceived before the COVID era and before the COVID pandemic. And so the idea was to allow us to come to Maputo and, let's say, work with you. And also the main idea was to allow you to come to Milan and work with us, and also attend our courses if of interest. And also the project has money to support 2 PhD candidates to carry out their PhD in computer science at Politécnico. Currently, we have 1 candidate, but we're still trying to find a second. And also, given that, let's say, apparently coming to Maputo is not as easy as, we thought of, let's say, 2 to 3 years ago, we have decided to start these series of talks and seminars, and this is only the first one. So we need to then design the others, and also you will receive proper flyers to advertise them. So the idea is to try to, let me say, keep the momentum, and also the idea is to allow you, and I mean you, everybody who wants to be online, to be aware of the project, which is called ICT for Dev, so Information and Communication Technologies for Development. And the idea is not only to, let's say, support very interesting things like, as I said before, allow people to get a PhD, but also maybe contribute to, I don't know, something there in Maputo. But also the idea, or at least my idea, is to work together. So to be able to share some ideas and to be able to then develop these ideas. And given that I'm a university professor, but I also tend to say I'm a researcher, let's say my final goal is always, the publication of, let's say, a reasonable or decent paper. So this is why, when we had to identify the first talk, there's a question on the chat, but I do, well, there's a sentence on the chat. But as I said, I can understand most of your Portuguese, but I cannot understand everything. So I'm sorry if you thought that the presentation had to be in Portuguese. Unfortunately, I can only speak Italian, or I can do my best with my English, and so my presentation can only be in English or Italian. Sorry about that.
Prof, don't worry about that. I was just reassuring the audience
okay.
that anyone who wants to ask a question can do it in Portuguese or English, and I will help if needed.
Thank you very much. So as I was saying, when we decided to start this series, and I hope that we can keep the original, let's say, plan of having a seminar or a talk, as I should say, every 2 weeks, so every other week, or in other words, every 15 days, I decided to start with, let's say, what I've been doing together with a bunch of young researchers. Well, the title maybe is a bit too old-fashioned, so over the last 15 years. Probably it's a bit too long, and maybe some of you were very young 15 years ago, and they are still much younger than me. But anyway, the idea is to try to give you an idea of what I've been doing, and also maybe try to identify some common interest or some, let's say, possible, I don't know, sparks for future cooperations. And by the way, let me point out 2 very important things. One is this, this is my email address. And so you are absolutely allowed to, I don't want to say to use it the way you want, because, it's my professional email address. But if you have questions, if you have comments, if you want to share ideas, or if you want to, in a way or another, let me say, work together, I'm always happy to discuss options and opportunities. And I'm sure that we can find a way to make it work within, let's say, the frame of this project. The other very, let me say, important or interesting information at the beginning is that you see a picture on the first screen, and there are some others over my presentation. So if you don't like my work as a researcher, as a university researcher, I hope you can like my pictures. So all the pictures you are supposed to see in my presentation, so in the next, let's say, hour or so, are, I was the photographer, so I was the one who took those pictures. And also, in a way, it's a kind of side result of my work, because, given the work, I really had the opportunity before the COVID to travel all around the world. And so I also had the opportunity to visit very interesting places. For example, I was in Maputo in February 2019, so almost 3 years ago, when we discussed the first ideas of this project. And also I had the chance to briefly visit Maputo, given that my week was mainly based on meetings and discussions with people there. So as I was saying, as I'm used to say, that's me before, let's say, starting Politécnico. Well, actually, it was a bit before that. But as the gentleman who introduced me has already said, I'm a professor at the Politécnico de Milano, where I tend to be, let me say, a software engineer. And I, in a very simple way, I'm very interested in every aspect that refers to the creation. So starting from the initial ideas down to the implementation, the operation and management of, let me say, any type of software system. So when I was a PhD student, I was used to work with a huge workstation, which was probably less powerful than my mobile today. Nowadays, we work with cloud computing infrastructures. Now we have started working on edge solutions. I've been teaching a course on design and implementation, on designing and implementing mobile applications. So I have plenty of students every year who implement sometimes very good, and in other cases just acceptable mobile applications. But my research interests, I would say, are in the big area of software engineering, whatever you think that software engineering should be. And if you're really interested, or if you cannot sleep overnight, here you see the URL of my official professional webpage, where you can find, for example, a list of my publications, if you care, the courses I teach, and also some teaching material there, but also, and this is extremely important, the names of the persons I had, and in some cases I still have the honor to work with. So, as already said, if you have questions, you can use your voice. You can speak Portuguese, English, and well, maybe if you can speak Italian, why not? But anyway, don't be shy, and I'm open. By the way, this picture was not taken in Mozambique, but I think it was taken, let's say, nearby, given it was South Africa, and it was unfortunately long ago. So, as the title suggests, I've been working on so-called self-adaptive software systems for now, I can tell you, probably too many years. And let me say that the key point of a self-adaptive piece of software is that we come, or I should say we came from a context in which the idea was I need to change my piece of software because of, the reason you like. I can, shut it down. I can apply the changes. So change the software, compile it, maybe test it, and then I can make it work again. But unfortunately, there are many, many cases today where, you cannot say, oh, now I shut down my system. I need, I don't know, 1 day, 2 days, a week to change it, to apply the modifications I have in mind. And then, as soon as I'm ready, I can make it work again. There are many software systems that must work forever, or let's say 24 hours a day, 7 days a week. And so their life cycle, the software life cycle is pretty famous and standardized, I would say, cannot be stopped once, the system has been developed. Let me give you a couple of very simple examples. At least in Italy, I don't know actually in Mozambique, but whenever, WhatsApp is down, it's probably the worst or the biggest problem you can think of. I think it was the end of last year. All the Meta or Facebook systems, so Facebook, WhatsApp, and Instagram, went down, and I think that they stayed down for some hours. And we had the news on the television, and every newspaper reported that unfortunately Instagram and WhatsApp were not available. But there are many other cases. For example, if you consider any cloud infrastructure, you cannot switch it off, modify it, and then make it work again. But also, if you consider the software in charge of managing, let's say, any service, your bank, the electricity, or the water system, or any system you can think of, they must be always alive. As such, whenever they are supposed to change, they must do it while they are in operation. It's true, and we will see it later. There can be many different ways well, there can be software architecture, let's say, that ease the work. I don't know, in these days, we tend to be crazy for microservices, or we tend to be crazy for function as a service systems, and many probably buzzwords. But the idea on which, let's say, we have been working for a while, and it was originally proposed by IBM, is that a piece of software, what is called managed element here, is nothing but, let's say, another type of system. And there are already many systems where you have sensors and you have actuators. And so the sensors, in our case, software sensors, are in charge of collecting the data you want to use in order to understand whether there's something to change. And then you have the actuators, which are in charge of applying, of enacting the changes. And the data you collect, they are transformed from collected data down to commands, down to concrete actions, by means of these 4-step loop, which is monitor. So you monitor the behavior of the system, you analyze the data you collect. Given the result of the different analysis you want to carry out, you plan for changes. And given the changes you have identified, you try to apply them, and you try to then modify the system while, let's say, it's in operation. This is the very general idea. But now let me also say that our work has evolved with respect to, let's say, the evolution of the information communication and telecommunication infrastructure. Well, it's not completely true that when I started this work 15 years ago, we were still, thinking of the waterfall development process. But it's true for sure that now we are in the era of agile development solutions, and also in the so-called DevOps era, where the development and the operation of a piece of software are linked together into a single loop. This means that's true. Probably 15, 20 years ago, we had so-called monolithic applications. Now, as I said, we are crazy for microservices, so tiny pieces of software that are supposed to cooperate. Years ago, we only had physical servers. So, for example, starting from my laptop, I was only able to use my laptop itself. Nowadays, we tend to deploy many pieces of software on the cloud, and as such, we use containers or functions. And also, as I said, when I was a PhD student, and it was unfortunately more than 15 years ago, let's say the cloud did not exist. But I would say that the cloud is around, has been around for probably, I don't know, 5, 6 years, maybe 10 years. And so we had to change our view of the world, and also we had to change our research. Okay, so that let me start from, let's say, the first example. I don't want to give you too many details, or let's say, I don't want to sound, let me say, as a real university professor. Not because my implicit assumption is that, you cannot understand our work. Actually, from my point of view, it's not too complex. But, given that I have 1 hour in total left, and maybe I would also love to have a bit of time for discussing and for exchanging ideas. Probably, it's better if I touch some results and some aspects. And then if you want to know more, as usual, you have 3 options. There is always a pointer on the slides, and I'll distribute a copy of the slides, let's say, just after this talk. You can ask, that's very simple. Or you can, as I said at the beginning, you can drop me an email message where, you ask for all the questions you want. By the way, as I said at the beginning, I think that one key point of my work is that, and I was very lucky, I have never worked alone. So all these results are always the results of a bunch of people, and especially, let me say, myself, which probably should be the last one, as the quote-unquote research manager, usually at least a PhD student who is or was part of the group in those days, and maybe some other people like postdoc researchers, other PhD students, and maybe also some visitors or master students. So the first case is the first system we developed. This is definitely the oldest one. It's called Dynamo, and it was developed together with a very smart PhD student whose name is Sam Guinea. Sam decided to stay with us for probably some 10 years. So he became assistant researcher at Politécnico after his PhD. But now he has decided to leave academia, and now he's involved in other activities. Anyway, let's say in those days, we were shaping, or the community was shaping the idea of web service. And also, so in essence, a web service, let's assume this service B here, is nothing but, let's say, a piece of software that you can interact with remotely. So there's no need you download the executable on your machine, but you can simply use it remotely. And today, we have many different examples. I don't know. Every time we use Google Maps, it's an example of a remote service. In those days, we were, the community was shaping this idea. And also there was this idea of being able to compose complex software systems simply by assembling, the calls to the different services in a very simple, workflow-oriented and graphical way. There was a language which was called BPEL, Business Process Execution Language. And I'm saying, I've said there was, given that now the language is dead. But the idea was simply to be able to compose a complex system, compose a workflow by saying that each node of the workflow here was nothing but, the invocation of a given operation provided by one of these remote components. Given that our idea was to work on self-adaptation, we basically created what is known as a typical control loop. So if you ask any, I don't know, mechanical engineer or any real engineer, they are absolutely good at, control loops. And so our idea was to say, okay, let's start from that technology, so BPEL. As I said, let's collect many different data types related to, let's say, the execution of our compositions. And then we simply applied the steps I have said before. So we were able to analyze the data by means of, let's say, simple rules. And then, given the results of the analysis, we were able to create what we called recovery actions. So the changes to apply to the service composition, which was running. So everything was done at runtime. So our rules, again, I don't want to give you boring details about this and that, but we simply defined, let's say, just, simple event, condition, action rules. So the idea was to say, okay, if you want to probe the execution of the service composition here, you decide that you want to retrieve the data from that specific point of the workflow, that you want to retrieve those data, and then you want to apply, I don't know, a given rule, a given predicate, I don't know, the value, the response time cannot be longer than X. And then if, the value is greater than X, then you apply a recovery strategy. I don't know, for example, you change the service you want to interact with. This was nice. The community, I have to say, every time we create a piece of work, the community is in charge of evaluating the work done. At least in my idea. So when I wear the hat of a university researcher, I know that I have to publish some papers, and these papers must be, accepted in good venues, because otherwise, I would say my university would complain. So, luckily enough, and this was 2011, so 11 years ago, we published this paper, and so basically Sam was happy because he was able to complete his PhD, and also he was able to get the position as assistant. But then in those years, and it was, as I was saying, some 11, 12 years ago, we were moving from physical servers to virtualized resources. And again, it's just a matter of evolution. So in the years, so in the first, no, it's better if I say in the second 10 years of this century, So let's say probably starting from 2010, 2011, the cloud has emerged as, first of all, a new opportunity. Well, it's not for free, but if you want, you can deploy your system in the cloud, and there's no need. You have a physical server to run it, let me say, at home. And it was also a kind of obvious or straightforward evolution of the SOA, so the service-oriented architecture, which governed, let's say, the previous 10 years. So we started saying, oh, come on, the cloud is not the solution for everything. In those days, we were really starting, but we cannot continue our work, let me say, as if the cloud does not exist. Clearly, we have to study it. It's a new, I would say, opportunity. And as such, we must try to embed it in our activities, in our research, as much as possible. So just to give you some buzzwords, I'm sure you know them. You can say now, let's say 10, 11 years later, that the work done with Sam was basically a piece of work done at the so-called software as a service level. So as I said, Google Maps is an example of a piece of software as a service. So it's a piece of software and it's a service we use. You can think of Gmail, you can think of Dropbox, you can think of many other services, let's say, which are not too specific and that we more or less use every day. But the cloud also offered us two other opportunities. The idea of having infrastructure as a service, roughly speaking, virtual machines. So now you can rent a virtual machine on any cloud provider in the world, roughly, and then you can run your software there, and also platform as a service. Nowadays, I don't know, you can develop, you can develop your piece of code, your software, and you can make it work, run it entirely on the web. So you can avoid installing, any editor, any compiler, any virtual machine, anything. And everything is done by means of these platforms that, work, as I said, as a service, but you could also say through the web. So the first idea, again, of merging these three aspects together resulted in this other paper, which was an invited paper. But the idea was simply to say, okay, whenever you have a problem at application level, so the one we were, let's say, aware of, maybe the problem is not at that level. So the problem is not that, the piece of software is not working properly. The problem could be, at one of the other layers. So for example, today we know that if a given service, if a given component gets too many requests, you can change the service. But the problem is that you should give it more resources. So instead of, for example, running your service on a single machine, you should split the system, use two machines, and then you should be able to route the workload on the different machines. So we started, working on this idea of having layers and of being able to predicate or consider the different layers all together. And so in those days, let's say, we had the pleasure to work with another nice person, Filippo Serracini, who, besides being Italian, he was a PhD student at the Department of Computer Science at the University of California, I think in San Diego. And don't ask me why, but at a given point, he dropped me a note saying that he wanted to come to Milan and work with us for a while. Then, let me say, After a while, we understood the real reason why he wanted to come to Milan, and it was because his girlfriend, or at least the girlfriend of those days, was living in Milan. And so, being in San Diego and having a girlfriend in Milan is not too easy. But anyway, we started working on that. And also we started considering the problem of managing virtual machines. So whenever you have a virtual machine, I'm sure you know what it is. So there's no need I introduce it. But anyway, while I came, or I was used to say, okay, I need Windows. I must have a physical computer on which Windows is running. I want to exploit my Mac, and then I must use Mac OS. Nowadays, you can simply use the web. Roughly, you can rent, as I said, a virtual machine, so a piece of a complete stack running somewhere in the world, and you can also decide that you want to exploit the operating system you need or you prefer. To be honest, you can also have virtual machines on your own laptop or on your own desktop. So nowadays, there are virtualization systems that allow us to create, I don't know, I can use Parallels to create a Windows machine running on my Mac OS computer. But anyway, let me put it in a very simple way. Given that whenever you rent a virtual machine, let's say you can consider the cloud provider you want, but on average, let's say they want to be paid, you must be able to, I don't know, foresee, you must be able to estimate the number of virtual machines you want. And the problem is not exactly the same as, I don't know, sizing the physical dimension of your system. Because, if you are supposed to buy servers, to buy computers, it clearly depends on the amount of money you have. If you need to rent these virtual machines, you can be more flexible. And again, given the budget, you can decide, when you need a given virtual machine. But the problem is that if you assume this level, so let's say this is what you can afford, clearly, whenever the workload is higher than the foreseen one, you have a problem. So you cannot serve it, and thus it's called under provisioning. Whenever you have a workload which is less than planned, so all the blue areas here, you're wasting resources. Let's say that these companies are not, they want to, make money. So if you rent a virtual machine and you don't use it, you are supposed to pay for it anyway. In those days, the idea was that, you were able to rent a virtual machine for at least 1 hour. Nowadays, I think you can even rent a virtual machine for 1 minute. I'm not sure you need to switch them on and off every minute, but you can do that. So let's say in a very simple way, the problem that we decided to study together with Sam and Filippo was the problem of allocating the virtual machines to the computations that we wanted to carry out. The idea is, the fewer virtual machines you rent, the cheaper the system is. And someone might also say, the more sustainable you are. But at the same time, you must be, let's say, smart enough to be able to allocate the resources you need. So you cannot say, okay, I rent, I don't know, 2, 3, 10 virtual machines, and then who cares? If I use them, well, that's okay. If I don't, I spare my money. This is not the way it works. So the problem is, if I have my budget, so I cannot rent more than, I don't know, 5 virtual machines, it's always good if I can, use those 5 virtual machines, and I can adjust the number of virtual machines dynamically given the real workload I'm supposed to serve. So this is why we did this work, and the work was aimed to address this problem. Here you can see many more names. I don't know why at a given point someone told us that besides Filippo, we also had to add Massimiliano and Ingold because they were part of the group in San Diego. While at Politécnico, we had myself, as I said, Sam, and also at a given point, I started working with Giovanni Quattrocchi, who is still in my group. And in those days, he was, let's say, completing his master thesis. Again, I don't want to give you too many details, but also we decided to exploit some simple, but let's say, smart applications to be able to probe our solutions. But because, of Filippo, and Filippo, let's say, he was a kind of expert in queuing networks, we decided to exploit these, let me say, theoretical means to be able to adjust the number of resources, as I said, the number of virtual machines to the actual workload. So if the workload is low, well, you can switch some virtual machines off, and then you can save money. But at the same time, if the workload increases, you can switch more virtual machines on, and then you can serve your workload. In this case, I'm used to propose this example. At least in Italy, it's a very Catholic country. So let's say if the Pope dies, or if the Pope resigns, many people want to know everything. And so, for example, if you manage the server of, let's say, the digital edition of a newspaper, you can be sure that the workload increases. But at the same time, probably after a few minutes, let's say the workload disappears because now people know and they are not interested in it anymore. Unfortunately, in this work, even if, let's say, we are researchers, so we are good enough at quote unquote presenting our results, but even if, let's say, the results were good enough, and I think this was a short paper. Yes, it was a short paper because of the 6 pages here, and the short paper was accepted. This work had the 2 key problems. The first one was that whenever you want to run a new virtual machine, running a virtual machine takes minutes. In those days, I'm not sure now, but in those days you needed probably 5, 6, 7 minutes to make it work. And as I said before, in many cases, the delay is too high. So people don't wait 6 or 7 minutes before they can be served. And the other problem, which was even more important, was that queuing networks are, let's say, a very nice theoretical means. I know almost nothing, but anyway, let's assume they are nice, but they don't scale. So if you have to model, let me say, a toy solution, they are good enough. But whenever you want to model a real system, then the computation, so the identification of the new amount of resources, so the new amount of virtual machines, takes too long, and that's why they don't scale. So that's why, after this first phase of the work, Giovanni started his PhD. And so, let's say, we decided to, actually, Giovanni proposed, to be fair and absolutely honest, to move a step further. So instead of, let's say, focusing on virtual machines, which were used, but they were already part of, let's say, our, I don't know, that they were already part of the state of the art, he proposed to move to containers. Well, again, I'm not sure if or how many of us are familiar with Docker and Docker containers. But the idea here is that whenever you manage a container, let me put it in this way. The main difference between containers and virtual machines is that whenever you have a virtual machine, you have the whole stack. So you move the operating system, you move the libraries you use, and clearly you move the software associated with your application. Whenever you have a container, you have something smaller. So the container or the engine in charge of managing your containers is based on a given host operating system. You can say that all the containers are supposed to share the same operating system. And then you only move your libraries and your code, which is smaller. And then, let's say, it can be much faster. I don't want to enter in the, let's say, never-ending discussion about the idea of microservice with respect to a standard service. So, for example, if you consider Adrian Cockcroft, which is one of the fathers, at least, of the technical infrastructure behind Netflix, you can say that the microservices architecture is nothing but a bunch of loosely coupled service-oriented architecture with bounded context. Someone would say it's SOA, so service-oriented architecture done right, small and focused on doing one thing well and autonomously. But anyway, the idea of having containers made us change the software architecture of the systems we wanted to address. And so we moved to, let's say, very componentized systems. And then you can say that each component, because of the period, is called or was called microservice. And given that I'm Italian, so Italians are famous for pasta, you can say that after the so-called spaghetti-oriented programs or architectures in the 90s, then we had layered systems, monolith layer system in the first years of the new century, and then now we have a ravioli oriented architectures because of these independent pieces. So the ravioli, as I said. So starting from this idea, we developed a bunch of, let's say, prototypes, and also, as I said, a bunch of papers. And let's say the team was composed by, again, myself, Giovanni, which was a PhD student in those years. And also we asked, for the help of a colleague, Alberto Leva, who is expert in control theory. So he's not a software person, but he is, someone who is in charge of controlling things. And, his help was key because this piece of work, let's say many years of work, was based on two key components. As I said before, containers, and especially Docker. So we used and misused Docker in many different ways. And let's say this was our answer, our solution to address the speed problem. So given that virtual machines are too slow to boot, we decided to switch from virtual machines to containers. Containers are extremely fast, so you can run a new container or a new copy of a container in, let's say, just seconds, just a few seconds. But also, in order to address the theoretical problem, so as I said, queuing networks don't scale, we decided to move to from queuing networks to control theory. And as I said, control engineers are very good at closing loops and at managing the loops themselves. And so again, I don't want, or I cannot give you the details of the control theory we used, I'm not even sure I'm able to give you too many details. But the problem is that whenever you have a controller, in terms of, as I said, control theory, it's based on a sound mathematical model. So it's either always correct or always wrong. Let's hope it can be correct. And, it scales given that it always takes the same amount of time. So it can be based on, it can be used in a very complex system or in a very simple system. But the time it takes is very controlled and it's extremely fast. Again, less than a second in many, many cases. So starting from these ideas, and given that, Giovanni was working on his PhD dissertation, let's say we conceived this idea of having, a bunch of containers. So first, a bunch of virtual machines or physical machines. Each machine was in charge of running a set of containers. And we were in charge of, let's say, coordinating everything. So we developed different controllers to make these systems work. Well, when I'm saying this system works, I'm saying that I want to be able to run these systems based on the idea of microservices and containers. But I want also to be able to save resources. So I don't want to spare money because I run more virtual machines or more containers than needed. So we started from, let's say, don't ask me why, but Giovanni decided to call the new system EcoWare. And also, let's say, this idea, so containers and control theory, well, I don't want to say that we have been selling the same idea for probably 6-7 years now, but let's say the same seeds, so containers and control theory, allowed us to work on let's say, of a series of different systems. And also every time we were able to address a different type of software system. Now I promise you the last paper on, let's say, which is part of this thread of work. I think it was accepted last year, if I'm not wrong, if I'm not mistaken. And then now we are trying to do something different. But so Giovanni started working on EcoWare. Don't ask me why it's called EcoWare. And the idea was exactly to apply containers and control theory on deploying, let me say, web applications. So whenever you have a web application, clearly you have a background, you have a backend component. And so you need to clearly replicate the backend in order to be able to serve the workload, or if you want to serve your customers. So we started this work. Again, it's already 3 p.m. in your case, so I need to hurry up a bit. But let me say that EcoWare was presented here, which was a nice conference, at least a very nice software engineering conference. And let me say that everything was implemented using Amazon, so within the framework of Amazon Web Services. We did it because, in those days, it was more or less the standard. And also, well, we had to pay for the cloud infrastructure. So we decided to use probably the most prominent one. And in those days, AWS, so Amazon Web Services, had this idea of having a rule-based controller. So it was able to instantiate a new virtual machine automatically. Let's say if the workload grows up to a given upper bound, but at the same time, it can switch a virtual machine off if the workload drops down and reaches a given other threshold. So we used as such AWS as the auto scaling embedded, which is still embedded as baseline, let's say a starting point. And then we moved to our solution, so control theory, used to control virtual machines. And the improvement was close to 80%. And also then we added containers on top of virtual machines, and the improvement was close to 160%. Very nice piece of work. Well, I'm definitely biased, but unfortunately, let's say the community almost ignored that, and Giovanni is still questioning why his work is almost ignored by the community. Then, because of the era we have been living, we decided to move to big data applications. I'm not sure, and unfortunately, I have no time to enter in the details, but we started working with a, let's say, kind of famous big data infrastructure, which is called Spark. And again, our problem was to work on, let's say, resource provisioning for this kind of different software systems. Again, you can run your Spark infrastructure on as many virtual machines or physical machines as you want. You can have, let's say, as many containers as you want, but clearly, if you don't use the resources you allocate, you waste money and the resources themselves. So in this case, let me point out that the problem is significantly different because big data applications, or at least big data applications running on top of Spark, are typical batch applications. So you create the piece of software and then you make it run, and the execution, given big data applications are supposed to work on tons of data. They might take hours, in some cases days. So it's nothing interactive like the web applications we started from. So again, we developed a completely different prototype, which is based on the same ideas. So we exploited Docker, so the containers, and also control theory. And we got a completely different system, which we called Dyna Spark, where Dyna stays for dynamic Spark, which is, let me say, a dynamic version of Spark that is a version of Spark that is able to allocate resources dynamically, given the actual workload and the actual number of big data applications you want to execute in parallel. Again, we have a very good publication on these, and the community ignored it. Let me also say that it took a while because we had to fight in order to, I would say, make the community accept our work. Because at the beginning they said, "Oh, come on, this is not software engineering. This is, I don't know, system management and operation. So why do you want to publish it on a software engineering journal?" But in the end, we managed. Unfortunately, the paper was accepted in 2019, and then we had to wait 2 years up to last summer before it was eventually published. So I have to say that, and here you see, our names: Luciano Baresi, Alberto Leva, and Giovanni Quattrocchi. Unfortunately, Sam, in the meanwhile, decided to leave academia. There is also assessment, so we had very good precision, but I don't want to be too boring. We also decided to, let's say, take a kind of side path because at a given point, someone asked us to analyze the Spark programs. When you use Spark, basically you can write your programs using, let's say, Python, or in other cases Scala, which is the parallel version of Java. And so someone told us, "Oh, but you assume that your Spark programs always execute the same way." And this is not the case, because if you assume you have simply an if statement in the code. Clearly, if you take one branch or the other, the execution could, change significantly. And then, let's say, the resources that you have to allocate. Then, again, we worked with another friend from a different university, so Giovanni Denaro. I do apologize. D. Giovanni should be G. Denaro, because he's a professor at University of Milan, Bicocca, so the second public university in Milan. And we conceived this other system where, we were able to, again, exploit containers and control theory to allocate resources given the actual execution of the system. Then the last change was that in these days, we don't have, let's say, a binary or Boolean word anymore. So my devices, let's say my laptop or my mobile phone and the cloud, but we have, a forest, or we might have a forest of very diverse devices and very different, executors. Don't ask me why, but someone has invented the idea of having edge computing when, the computation is carried out towards the edge of the network. There's something in between that, given that we had clouds here, someone called them fog nodes or fog computing. And again, we have the cloud itself. This means that it's not just a matter of moving from your local device to the cloud, but you have many different layers in between. And in those days, I had the opportunity, or as I said before, the pleasure to work with two other persons, Danilo Filgueira Mendoza. I do apologize for my terrible Portuguese. Danilo is a very smart student, PhD student who came from Brazil and who spent 4 years in Milan working with us. Because after completing his PhD program, he stayed one additional year because he liked the city. And also, I had the opportunity and the pleasure to work with Martin Gavija, who came to Milan from Argentina, and he came as a postdoc because, again, he wanted to work with us, and we had some money to support a postdoc student. Again, given it's already almost a quarter past, let me say that we started working on this kind of edge-based solutions. And again, roughly, let's say, we started, or we kept working on our two pillars, so containers and control theory. And we added, or let's say, we have added many other aspects. Last but not least, nowadays, we have machine learning. Let's say AI is almost everywhere. And, in order to be able to run or to create machine learning models, so ML models, efficiently, we tend to use GPUs in order to, let's say, speed up the computation of these models. And so it's not just a matter of, let's say, controlling the CPUs, and then, let's say, controlling the CPU cores, the amount of CPUs associated with the different containers. But now, let's say, the context is more heterogeneous, because we have both CPUs and maybe some CPUs. And so this is why we developed Roma. Again, I know that Roma is a very nice city in Italy, but I have no idea why my young co-authors decided to call it Roma. And again, it's yet another system where we try to self-adapt, as usual, the amount of resources in terms of CPUs and GPUs associated with the different systems. But in this case, as I said, they are ML systems, so they are machine learning systems. In the meanwhile, you see here that we also hired another postdoc, Nicolas Rasi, who stayed with us for some 2 years, just, you know, the 2 years of the COVID era, and he left mid of February this year. In the meanwhile, let me also say that we moved to Microsoft Azure because Microsoft was so kind to offer us a grant to use their cloud infrastructure for free. And so instead of paying, you know, AWS, we decided to migrate to Azure. Okay, I know that I have only touched, let me say, the work done. As I said, I only have some 15 minutes left, so I think it's time to wrap up, and also maybe time to listen to comments and questions. Let me just, you know, conclude with a few final remarks and maybe some ideas for, you know, of what we are doing or we have been doing right now. So first of all, well, I've been working on self-adaptive systems. I think that honestly, now I can say that probably we have speculated a bit too heavy on this idea of containers and control theory. I have to say that we have published a good bunch of papers, and also, you know, published on, you know, good journals and presented at good conferences. But I have to say that given that we are software engineers, or we tend to say we are software engineers, the community has not really, how can I say, liked our work in terms of, for example, number of citations. And I must also say that, you know, in these days, given that this idea of DevOps and this idea that, you know, you can create a new container running a new piece of software, a completely new piece of software, I'm not sure that, you know, you need to be able to self-adapt. You can simply react whenever you are supposed to do that. So honestly, these, you know, has been the past. Probably someone might say, oh, you know, after, you know, applying your idea on so many different software types, you might try with what is called serverless computing nowadays. I think that in a way or another, we have already done it, but I think I'm done. I can stop here. Now, let's say with Giovanni, who is still working with us, and also with a couple of new, young, energetic resources, we have been working, or we have started working on some new ideas. Well, I cannot tell you that, you know, we won't exploit some old concepts or some old results in this new area, but just to focus on some, let's say, buzzwords. One of the persons who is also partially supported by the project has started working on blockchain technologies. You know that in these days, we all are crazy for security and privacy. I'm not a security person. I have colleagues in the department who are experts on that. But again, our interest in blockchain technologies and blockchain-based systems, like you know, the Bitcoin solutions or the other well-known systems, is again at the level of, you know, the complete software system. So we are interested in understanding, for example, how to engineer a blockchain-based system, and also we are interested, let me say, in understanding how to make it work. Because in these days we have many examples, but they are mainly toy examples. Then, because of another project, which was accepted last year, we have started working on so-called federated machine learning. So the idea of federating the machine learning process is that in many cases, the data are collected on many different devices, and you cannot move the data to a centralized component because it's too heavy, and then let's say it would take too long, and it's also against the privacy of those who collected the data, for example, by means of your mobile devices. So a way which is often adopted in these days is that you carry out the machine learning process on the device, let's say where the data are generated, and then you move the result in order to compose a single ML model. And again, in our view, this is yet another instantiation of a self-adaptive system. Then this is mainly a dream I'm working in these days because of a new proposal that I'm crafting. That the community, so the computer science community, now is crazy for what is called quantum computing. It's a different type of computing machine. Clearly, I'm not expert in the hardware part of these systems, but I think that we need software engineering results from, for software engineering solutions there in order to make quantum programs work. As I said, I've been teaching the course on designing and implementing mobile applications for probably some 10 years now. And I'm still very interested in what is called cross-platform mobile applications. So roughly, mobile applications that can run both on Android and iOS without developing them twice. And last but not least, a new PhD student who started November last year is now working on, again, software engineering for AI. So how to manage AI-based systems by means of software engineering techniques. So I'm not, changing my hat. I'm too old. I'm gonna be 55 next Friday, so basically tomorrow. But I want to understand how software engineering can help this kind of new software systems. Sorry about the too long speech, and I had to skip some details, probably boring ones. I think I have had the opportunity, and I thank you, to present my work, to present the different results I have obtained with my young and talented colleagues, and I have to thank them because without their heavy work, all these results wouldn't have been possible. And now, if you have comments or questions, I'm definitely happy to answer them.
Thank you so much, Professor Baresi. This is indeed quite a huge dream. I don't know how you were able to unpack so much in just an hour. I'm bursting with questions here, but I'd rather first let the audience intervene. Colegas, este é bom momento para tirarmos algumas dúvidas, caso existam. Sintam-se confortáveis em perguntar, tanto em português como em inglês. No início, o professor Baresi alertou-nos que ele consegue perceber bocado do português e, se necessário, também posso ajudar. Então, escolham a língua conforme preferirem.
Hello.
Hello.
Thank you, Professor Baresi, for the presentation. It is quite interesting what you've been working with. I probably joined a little bit late, so I might ask a question which you have probably already addressed. But when I first heard and I heard it like last minute that there was a presentation about self-adaptive software. The first thing that occurred to me that this is probably connected to some kind of personalization or adaptations that have to do with meeting user-specific needs, maybe by ways of analyzing data to respond mostly to business requirements or adaptations connected to changing design aspects of the software, or more in that sense. But it seems that this is on a it's focused on a different direction.
Please.
Yeah. So I wanted to ask more like a clarifying question on if you could explain it in simpler.
Yeah. I think that you are absolutely right. So you can say that one of the reasons you have to adapt or to self-adapt your piece of software is because, you know, requirements change, or because you want to, I don't know, address a different family of users, and this new family of users have has some specific requirements. So I absolutely agree with you that, you know, whenever you have to adapt or self-adapt, you must have a reason for that. Let's say, the reasons we touched are mainly when we started. So with the first piece of work, the self-adaptation of service compositions was roughly in the way you described. So we wanted to change the piece of software that, you know, people were able to use. Then we decided to move, let's say, at infrastructure level. I didn't mention it explicitly. Sorry about that. And we decided to pay more attention to the amount of resources used to run these systems, because, as we said, you know, if you can use your money in a smart way, it's always good. But I agree, you're right. What you said is another possible dimension or another possible reason why you should or you can adapt or self-adapt your software. And definitely it's worth of investigation. We didn't, but why not?
All right, I understand. So my second question, a comment question, so to say. When we talk about adaptive software in terms of it adapting to respond to demands to the infrastructure, when we say system, you are, because the thing is, in my mental model, how I understand it, I have always detached the software from the infrastructure, as the infrastructure is acting as, I don't know, as a controller, kind of making sure that the software is running at the optimal performance. When we say self-adaptive, we mean that the software is going to, let's say, inform this infrastructure platform or component of its needs, and then the infrastructure is going to provide to those needs. Because as I've understood how the architecture works, the infrastructure is constantly monitoring all the components that are running over it, just like an operating system is monitoring the applications that are running on it, and is allocating resources so that they can run at the best performance. It's not, so the adaptation in this sense, is it part of the software? Like, how is it part of the software to be self?
Let me, I think that your analysis is absolutely correct. And probably I didn't stress this aspect as I should have done. But let me start from here. So if you consider that you develop a piece of software and you run it on your computer, You mean your computer is your computer, so you cannot change it. Or, well, you can always buy a new one, or you can always buy another one, but you cannot change it, dynamically. It takes a while. If you consider the opportunities offered by cloud computing or by this idea of virtualized resources, is that, in a sense, the infrastructure on which you run your software becomes part of the system itself, because you can change it and control it in the same way as you manage your software. So you can run a piece of Python or a piece of Java to rent a new virtual machine and to use it to execute your software. So you can say that you have a piece of Java which is in charge of saying that whenever the workload reaches a given threshold, then you keep allocating a new virtual machine. So when I said system, my idea was to mean that it's not just the usual, let me say, software at application level, but you must also consider, if you want, the infrastructure on which the software is running, because it's now controllable by means of software, and it's virtual. So you can decide that you need 10 virtual machines now and one in 10 minutes, or one now and 100 in 10 minutes.
Interesting. Yeah, that's quite interesting. So in terms of how we engineer software, the proposal is mainly that we need to take into account not just the business requirements we're trying to solve, but we need to think ahead on infrastructure requirements and
at least this is the message we have been trying to communicate over the last probably 4 or 5 years. Yeah, I agree.
Amarildo,
yes.
Let me ask you to pause now. You see the email here. I think that you and Prof. Baresi have an interesting paper ahead.
Yeah, I'm definitely, as I said, I'm always happy to discuss my ideas and to
please
work
use this
with
email. I think you have an interesting
work with
paper ahead.
new people. Unfortunately, I have to leave, let's say, in 5 minutes at the latest, because I have another meeting, and I have meetings in a row today, but I can take probably another question or two. I would like
Prof, we have another question, maybe the final one in the chat box from our
the
colleague
one by
Leila.
Okay,
maybe you could take that
sure.
That one, and then we wrap it up.
Yes, I have two answers. One is from our point. Okay, let me be clear here. My work is not on, let's say, changing the machine learning algorithm. I'm not in that business. I can give you pointers to colleagues who are very good at that. So my idea is, for example, that given a well-known ML algorithm, if you, let's say, play a bit with the parameters, so if you change the configuration of the same ML algorithm, you can, for example, save resources or increase the quality, so precision and recall of the result. And again, instead of configuring the ML system beforehand, when you deploy the system, and then whatever the system produces, well, you accept it. Our idea is to move these parameter tuning at runtime in order, again, to be able to, let's say, obtain, I would say, the best result with a consistent number of resources. But as I said, we are not able, sorry about the ignorance, we are not able to change the way, so the internal way the ML algorithm works.
Leila, was this clarifying enough?
Well, if you are interested in knowing more, I have a master student who is finalizing her master dissertation exactly in these days. And if you want, I can send you a copy. It's just a PDF, and then
Fantastic.
you can do whatever you want. If you send me a message, so an email message, just as a reminder, I can then send it to you.
That's perfect. Colegas, eu penso que este é o momento de libertarmos o professor Baresi. Já esteve conosco por um pouco mais de 1h30. Acabo de pôr no chat 2 e-mails que podem usar para contactar, pedir mais informações, procurar colaboração, saber mais sobre as bolsas de PhD disponíveis dentro deste projeto. E não hesitem em usar esses contatos, conforme o professor Baresi mostrou total disponibilidade, e através do Centro de Informática também podem fazê-lo. And Professor Baresi, once again, you honored us with these 2 hours of wisdom.
Yeah,
and
it's
we seriously hope that we'll get another chance to pick your brain in other subject matter that we know that you are an expert on. Thank you so much.
Absolutely. It's my pleasure. Thank you very much for listening. And I hope also to be able to come to Maputo soon and maybe chat with you.
We noticed that your camera still owes us a visit.
Yeah, chat with you, let's say face-to-face in a more live fashion. Now, I do apologize. Thank you very much. It was very kind. You have my email address here, but I must jump to the next meeting.
Perfect.
Sorry about that.
Bye-bye.
Thank you. Bye-bye.
Tchau a todos. Obrigado por participarem. Tchau.
Tchau.
Até o próximo seminário. Vamos partilhar mais posters dos outros seminários. Tchau.
Bye. Thank you.
Thank you, Francesca.